Hi everyone, my name is Trang Bui, and I am a student at the University of Manitoba, Canada. I am presenting my research experience with the BL3 collaboration. I am deeply grateful for the support from the Canadian Institute of Nuclear Physics. Over the past summer, I have been working on the project simulations of protons in the beam lifetime 3 toward the object, characterize proton reaching the detector, and determine how metallization on silicon affect the detection parameter. So the background of this experiment is the world average of neutron lifetime is approximately 15 minutes. However, the beam method and the ultra-cold neutron storage method gave the average values that currently differ by 8.7 seconds, which is 4 standard deviations. The BO3 experiment, which is spanning more than 3 decades at the NIST Center, aims to improve the precision of one of the beam time measurement to resolve this discrepancy. The present goal now is to decrease the uncertainty in the experiment to 3 seconds. In the project, a neutron beam passed through a quasi-panning trap and decay proton trap electrostatically between the mirror electrode at positive 800 voltage, center trap electrodes at 0 voltage, and door electrodes at positive 800 voltage. And the decay protons are also trapped magnetically by an axial magnetic field that do not vary by more than 0.2% of its average. When enough decay protons have been accumulated, the trap will open and the decay protons in the trap follow a band in the magnetic field to a silicon detector where they are counted. We studied the motion of protons moving around the BO3 trap by running a program called Cassiopeia, developed for the Catherine experiment in Germany. The Cassiopeia-based simulation uses multiple expansion for the electric field and the magnetic field, calculated from their current distributions, which allow more easily to change in the field geometries to determine the distribution and the trap efficiency. We simulated 3 million events in Cassiopeia, collecting approximately 60% of total events that reached the detector, and plotting those kinetic energy, final time distribution, and positions of these events hitting on the detector plane. As you can see in the left side of part figures in my presentation, we also use a program extreme stopping and range of ions in mirror, with simulating hydrogen atoms to the target layers to determine the dead layer effects and the charge sharing in the detector, and comparing them with different material of the dead layer. With the silicon active layer, the first plot in the right side of my presentation shows the difference in the collision inside the dead layer and the active layer. The other two plots on the right side compare collision range inside the detector and energy distribution along the depth between gold and silicon dead layer. These plots highlight the difference that determines the detection parameters. By using and comparing these simulation tools, we are assessing the performance parameters for the BL3 experiment. Thank you for attention.